We're starting relations and functions now in our brand new unit. So an ordered pair is a set of inputs and outputs, and that represents a relationship between two values. A relation is a set of inputs and outputs, and a function is a relation with one output for each input. Another way to say that is for each x, there's only one y. So we're going to look at several different ways that we can represent relations, and then we're going to determine whether those relations are functions. So one way that they could be presented to you is just as a set of points. And each of my examples here has 4 sets of points in them, but it could be any number of sets of points. So it doesn't have to be 4. It could be 2. It could be 7. It could be 400. We're just going to look at 4. Okay, so each of these are relations. They're inputs and outputs. The x is the input, the y is the output. And I'm just looking to see if each input goes with exactly one output. So if x is 2 in this one, the y value is 1. And if I look at all of the other x values, none of the others say the x is 2. So I know for sure that if x is 2, y is 1. That would be a functional relationship. I need to do that with all of the x's though, so I'm going to look at the next one. If x is -3, I know that the y is 5. And if I look at the other points that are there, the x is never -3 again, going with a different value. So that one's functional as well. My next x is a 7. And if x is 7, the y value that goes with it is 4. And so if I look at my other point there, the x value on this one is not 7. So that means if x is 7, I know for sure that y is 4 on this one. And then the last point has an x value that's different from all of the others as well. So this one is a function. Okay, now I want to look at the one that's right underneath it here. So for this one, I'm looking at the x values again. For each input, there has to be exactly one output. So this input is 2. And if x is 2, this point says that the y is 1. But then this point says if x is 2, then the y is 5. So that means this single x value goes with 2 different output values, 2 different y values. So that makes this not a functional relationship. I don't even have to look at the rest of them. It only has to happen once in order for it to be not a function. Okay, now I'd like you to try these 2 here on the right. So you're going to pause the video here for just a moment, and then you'll examine these 2 relations and determine whether or not they are functions. All right, welcome back. In each of these, the x values, each x value goes with only a single y value. So both of them actually represent functional relationships. Right, another way that you could see a relation and could be presented is in a table. And in a table, a function includes no repeating x values. And so it's kind of the same concept there. Now again, each of the tables that I have on here includes only 4 values, but the table could have many more inputs and outputs. It doesn't have to be 4. It could also have fewer. It could have 2 or 3 or even 1. That would be a really boring table. But anyway. Okay, so to determine whether these relations are functions, I'm going to look for repeating x values. Now, not only does the x value have to repeat, but if it does repeat, it has to go with different y values over here. So first I'm going to see if any of the x's happen more than once. So 1 occurs only once, 2 occurs only once, 3 occurs only once, and 4 occurs only once. So with this one, I don't even have to look at the y values. I can say that this is a function. Looking at the second table here, I notice that I see the same x value twice. There's one here, one here. So I'm going to look at the y values that go along with those. If they're the same value, then this could still be a function. But the y values, the output values that go along with those x's, or that x, I should say, because it's the same one twice, is different. So that actually makes this one not a function. Now you're going to pause for a minute and try this third table and determine whether or not that one represents a function. Okay, hopefully you determined that one was a function. None of the x's ever repeat. This one has pi or negative pi as the y values, which is kind of interesting. But we didn't even need to look at the y values on that one to determine whether or not it was a function. Another way that we can represent a a relation is by what's called a mapping. And a mapping is really just kind of a pictorial representation of that relationship. So on the left, you'll have your input values or your x values, and on the right, you'll have your y values. And a lot of times they use these oval things here, but these shapes could be any shape really. So you could have some weird shape looking like this and just have it full of numbers or letters or whatever. And then another weird shape like that over here. And then arrows going from one to the other. The way a mapping works is you've got your input values on the left, and then there is an arrow that directs the input value to an output value. So for this first one, it says that if x is a, or the input is a, then the output is 1 or 3. If the input is b, the output is 2. If the input is c, the output is 3. And if the input is d, the output is 4. Now, to determine whether or not this one represents a functional relationship, each of the input values has to go to only one output value. So a simpler way to say that is the arrow here can only come from one of the input values. That was not really clear. You can only have one arrow coming from the input values. That's what I'm trying to say. So with this one here, because this input value goes to two different output values, this one would not be a function. Okay, looking at the second mapping that we have on here. Again, we've got inputs on the left and outputs on the right. So I'm going to look at my input values and see if each input value goes to only one output value. So 3 goes to 2, only one arrow coming from 3. 2 goes to 4, only one arrow coming from 2. Negative 6 goes to negative 2. So again, only one arrow coming from 6. Negative 2 goes to 1, so only one arrow coming from negative 2. And 0 goes to 1, so only one arrow going from 0. So for each of our input values, there's only one arrow coming off of it. So this one is a function. Now you'll notice down here at the bottom that 2 of the input values go to a single output value. That doesn't violate the functional relationship. So this is still a function. All that has to happen is there only one arrow coming from an input value. Relations can also be represented with graphs, of course. And the graph could be a function, or it could be something that's not a function. And so the way that we test that is in a functional relationship, no 2 points lie on the same vertical line on the graph. So one way that we could test that is by what we call the vertical line test. So let me see if I can get a nice vertical line in here. I'm not seeing any shapes, so I'm going to have to freehand it. Okay, so to test this one to see if it's a function, I'm going to draw in a vertical line somewhere on the graph here. And I'm going to see how many times that vertical line intersects the graph. This one intersects only once. Now I actually have to test that for all possible places on this graph. So any vertical line that I could possibly put on here. So So I would think about that as if I just like took this vertical line and slid it around on the graph. As I moved it around here, like maybe I got to right here, well, that vertical line still only intersects the curve one time. And that would actually happen for any vertical line that I drew on this graph. So that makes this a function. We would say it passes the vertical line test. So now looking at the other two graphs here, this may be a good time to go ahead and pause the video and see if you can determine whether or not these two are functions. All right, welcome back. So this first one definitely is a function. That's just a line. So it's a linear function, in fact. It does pass the vertical line test. I could draw a vertical line on here anywhere, and it would only intersect that line once. The third one, however, this circle, I drew a vertical line on here just to show it. That vertical line, okay, it's mostly vertical. It's a little bit crooked, but it does, in fact, intersect the picture, the relation, more than once. It intersects twice here, and it would do that in a bunch of places, but it actually only has to happen once for this relation to not be a function. So this one is not a function.